right, welcome back. Geometry. We are on Unit 5, Big Ideas. Remember, Unit 5 was this unit that we just recently covered, so we didn't have a chance to take a test on that yet. I believe we'll be doing a take-home test at some point next week, so check your Remind in your emails and your Schoology or your Google Classroom for more updates on that. All right, Unit 5 is Algebraic Connections to Geometry, so it's got a lot of algebra in it. All right, we start off with standard form and general form of a circle. So here's our standard form of a circle equation, and here is our general form. You'll notice that we can get some more information from the standard form, right? We get the center of the circle and the radius of the circle. Notice on here the way that we've ordered everything on the general form. The x squared comes first, followed by the y squared, then the x term, the y term, and the constant, and it's always set equal to 0. All right, so remember we went from standard form to general form, and then we went the other way, going from general to standard. It's important to get things into standard form to know the center and the radius of the circle. All right, so we'll start off just by identifying the center and the radius with each of these equations. So if you'll look, you'll notice that these subtraction signs are part of the equation. So if they're part of the equation, they're already built in, right? So if this is a minus 1, that minus is part of the equation. So your h is actually a positive 1, right? And since this subtraction is built into the equation, the fact that we have a plus means the 3 must be negative, because if you're subtracting a negative, that turns into a plus, right? So basically what that means is we're always going to have to switch the signs to get the center of the circle. So since that has a subtraction, this is going to be a positive 1. And since this is a plus sign, that's going to be a negative 3. All right, now for the radius, we look at this number right here. Don't be tempted to just pull this number. That number is radius squared, right? So to get to the radius, we're going to need to take the square root of this number. So our radius is actually going to be the square root of 4, which is 2. Our radius is 2. Now the square root of 4 can also be a negative 2, right? But not for this unit in geometry because we can't have a negative radius. So our only option is a positive 2. All right, pause the video and try these two on your own, and then come back when you're ready. All right, I know all my students paused it and tried it, so we're going to go over these quickly. We just switched the signs, right? So our center here is going to be a 2, negative 1, because we switched them. And then we take the square root of 16, which gives us 4. Our radius is 4. So looking at it, which circle is larger, the first one or the second one? Hope you're saying second one because our radius is bigger, right? So every single point on this circle is 4 units away from the center. Every single point on this circle is 2 units away from the center. All right, the next one, 9, 4, because they're both negative in the equation, right? Now here, this might have been a little tricky because when we take the square root of 14, it doesn't give us a integer like these two did, right? So you found that out by going to Desmos on your Desmos app or desmos.com and doing square root of 14. It gives you a decimal. This is my dog Spencer. I'm sure you'll hear him in the background at some point. Okay, so I want you to write this in the most simplified radical form. So what you're going to do is you're going to find factors of 14. You did this in your first unit in algebra last year, so this is just a refresher. So two numbers that multiply to get 14 are 7 and 2. Neither one of these are perfect squares, right? So this is simple as it gets. So I'll keep this at square root 14. This is my final answer. If there were a perfect square in here, we would pull it out of the radical. So maybe at some point during the notes we'll have a chance to do that. I know you're excited. All right, now for these next two examples, it looks like we're going to have to graph here and then find the center and the radius and actually write the standard form equation. All right, so it gives us the center and the radius, so I can go ahead and put that here. 2, negative 5, and a radius of 3. All right, so plotting the center. The x value is 2, so I'm going to go right 2. The y value is negative 5, so I'm going to go down 5. All right, that's the center of my circle. Now I know the radius is the distance between all points on the circle from the center. So since I have a radius of 3, I know that there's going to be a point 3 units above. 1, 2, 3. There's going to be a point 3 units to the right. 1, 2, 3. A point 3 units down. And a point 3 units to the left. All right, once I have those 4 points, I can connect them as best I can. Oh, look, I'm getting better. I was getting nervous right at the last part when I'm doing a good circle. All right, so here is my circle. Now I need to write the standard form equation. So remember, if you go back up here, we're just going to plug the center in for h and k, right? So essentially, we need to change the signs to fit it into the standard form. So looking at this, it's a positive 2. So to write it in standard, I'm going to write x minus 2 squared plus y plus 5. The plus comes from the fact that this is a negative, so we're changing the signs to put it in. Don't forget your squares after these two binomials. Remember, I told you that this standard form was derived from the Pythagorean theorem. So it's something squared plus something squared equals r squared, right? So our radius is 3. So we'd have to square 3 to get the right side of this equation. So our final simplified form, x minus 2 squared plus y plus 5 squared is equal to 3, because 3 squared is 9. All right. Now this next one, they give us a graph and they ask us to find the center and the radius using the graph and create the standard form equation from that. So go ahead and pause your video and attempt to do that on your own. All right. Hopefully you've attempted this on your own. So let's see. We can easily get the center, right? Negative 2, positive 1. Remember, the x value comes first, and the y value comes next. So negative 2, 1. Now for the radius, I can just count over and see how many units it takes to get from the center to the outside of the circle. So 1, 2, 3, 4, 5. Looks like my radius is 5. 1, 2, 3, 4, 5. All right, so I'm ready to write my standard form equation. Remember, we're going to flip the signs when we put it into the standard form. So now this is going to be x plus 2 squared plus y minus 1 squared is equal to 5 squared. So our final equation is equal to 25. All right, great work on that. Let me see if I can zoom out. Okay. All right, here's where it gets a little trickier. Find the center and the radius described by this equation. All right, well, it'd be nice if this equation was in standard form, because then I could easily pull the center and the radius from the equation. But it's not. It's in general form. So to go from general form to standard form, we have to do that process of completing the square. All right, so our first step in completing the square, and I'm going to rewrite the equation over here, x squared plus y squared minus 4x minus 6y plus 8 equals 0. Our first step in completing the square is always going to be to move the constant to the right side of the equation. So step 1, move constant to the right side. All right, and our constant is our number that doesn't have a variable next to it, right? So our constant's 8. It's a positive 8 plus 8, so the inverse operation of addition is subtraction. So to move it on the other side of the equal sign, I'm going to subtract 8 on both sides. That cancels out the 8 over here. Now, when I bring everything down, I'm going to group variables together. And add spaces to my equation. Group variables together and add spaces. So by group variables together, I mean I'm going to put the x values together and add a space in my x group, put the y's together and add a space, and then I'll add 2 spaces to the other side, right? Because what I do on one side, I must do on the other. All right, so let's start off x squared. Now what comes next is the minus 4x, because they both have x's, plus a blank. That's for our x group, right? Plus y squared minus 6y plus a blank for completing my y group. is equal to, now remember we moved this negative 8, we moved 0 minus 8 is going to give me a negative 8, right, from my last step. And then I'm going to have plus 2 blanks, right? This blank goes with my x group. Whatever I add on one side, I must add on the other. And this one goes with my y group, right? All right, so how do we determine what actually goes into the blank? All right, well, what we do know is we look at the middle term. I have a negative 4. What I need to do is divide that term by 2 and square it. So let me write that down. Divide middle term by 2 and square it. All right. So negative 4 divided by 2 gives me a negative 2. Negative 2 times negative 2 is going to give me a positive 4. So again, let me do that in Desmos just so everyone could actually see what I was doing. All right, so what I did was negative 4 divided by 2. That gave me a negative 2. Now I can write this as negative 2 squared, or I can write it as negative 2 times negative 2, and it will give me a positive 4. And that's how I get my blank right here. So what I do on one side, I must do to the other, so I'll put the 4 here. Now let's do the same thing for this y group, this y middle term. I'm going to take negative 6 and divide it by 2. That's going to give me negative 3. Negative 3 squared is going to give me 9. So I'm going to put 9 here and 9 here. All right. So that was actually completing the square. Now what we did when we completed the square was create 2 perfect square binomials. So let's look at this x group. And I can rewrite this. This trinomial right here can be rewritten as a binomial squared. Binomial is 2 terms instead of 3, right? So I can rewrite this as x minus 2 squared. Where did the minus 2 come from? It's just the first part of step 3, dividing the middle term by 2. So negative 4 divided by 2. So if you look at this, if I expand this out, multiplying using FOIL or box method, I'll end up with this trinomial. These two are the same thing. All right, plus, what will my y group end up being? If I take that middle term and divide it by 2, it's going to end up being y minus 3. It's starting to look like a standard form equation. So all we did was factor the x group and the y group. Now let's combine like terms or simplify over on this side. So all I'm going to do is just combine all these 3 terms. So negative 8 plus 4 plus 9 gives me 5. All right. So from here, now that I've got it in standard form, I can easily identify the center and the radius, which is what the question originally asked me for. So my center is going to be 2, 3. They're both positive because these subtraction signs are in the formula. Now be careful, my radius is not 5, it's the square root of 5, right? Because this is r squared. All right. Great work on that. All right, the bottom here. How to find the radius of a circle given the center and a point on the circle. So basically what we're given is we're given the center of the circle and then a point on the circle. So how do I find the distance between those 2 points? I hope that hint was enough. Use the distance formula. To determine the radius. Remember, the center is the same distance away from all points on the circle, despite my crazy picture. All right, so is a point on the circle? Well, what you do is you would use the center and the point given, plug it into the distance formula, and if it is on the circle, your answer is going to equal the radius. All right, go ahead and go to video 2, and we will keep working on this Big Ideas packet.